Good morning, dear students. In today's lecture, we will start our new chapter, that is S block elements. Remember, the periodic table is classified into 4 blocks. And the 4 blocks are S block elements, P block elements, D block elements, and F block elements. There are elements which belongs to S block, there are elements which belongs to P block, there are elements which belongs to D block, and there are elements which belongs to F block. Now, which elements belongs to S block, which elements belong to P block, which elements belong to D block, which elements belong to F block? That we will talk later on. But before this, let us talk about the two important definitions from this chapter, and the two important terms are ionization potential and electron gain enthalpy. These points or these definitions are part of chapter periodic classification of elements. But as it will be used here, that's why we are talking about these two important definitions. Term first is your ionization potential and term second is your electron gain enthalpy. Now, what do we mean by ionization potential? It is also called ionization energy. What is the meaning? What is the definition? About the definition, the energy required to remove the most loosely bound electron from an isolated gaseous atom is called ionization energy or ionization potential. Most loosely bound electron means we are talking about valence shell electron. Atom should be isolated. It should not be in contact with other atoms. And it is possible only in gaseous state. So why we are using isolated gaseous atom? So that we can get the exact value of ionization potential. The exact value of energy required to remove the electron from the valence shell electron. If some other atoms are there, then definitely the valence electron will feel some force of repulsion from the electrons present in the other atom. It will feel some force of attraction from the nucleus of the atom. So energy required will not be exact. We want the exact value. That's why the atom is taken as isolated gaseous atom. So if we provide ionization potential or ionization energy, then atom will be converted into ion. The electron will be completely removed. So again the definition, the energy required to remove the most loosely bound electron from an isolated gaseous atom is called ionization potential or ionization energy. Simply it is represented as IP. Now representation, M gas. M represent isolated gaseous atom. When first IP is provided, then it will be converted to M plus ion in gas state with the removal of electron. We will obtain univalent cation, unipositive ion. Now, then it will be converted to M plus 2 gas with the loss of electron. And similarly, if M2 plus gas is provided IP3, then it will be converted to M plus 3 gas with the loss of electron. So when IP1 is provided, neutral atom will be converted to unipositive ion, cation. When IP2 is provided, then the unipositive ion will be converted to dipositive ion. And when IP3 is provided, then dipositive ion will be converted to tripositive ion. In this manner, electron will be removed. Now, on what factors value of IP depends? So before we talk about factors, let me tell you about its unit. As atom is the smallest unit of the matter, so energy required to remove the electron will be very less, and that's why we use the smallest unit of energy, which is called electron volt. The unit here will be electron volt, EV. 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. Remember this. Now about the factor. What we are doing? We are removing electron from the valence shell electron, from the valence shell. We are removing valence electron, or electron is removed from valence shell. Energy is required. Why it is required? Because there is a force of attraction between nucleus and the valence shell electron. And against this attraction, we have to supply energy. So when energy is supplied, electron is removed. If valence shell is closer to nucleus, if atomic size of atom is small, then valence shell will be close to nucleus. There will be more force of attraction on the valence shell electron. So removal of electron will not be easy. In that case, we require more amount of energy. And if the atomic size increases, then valence shell moves away from the nucleus. The distance between the valence shell and nucleus increases. If the distance increases, then force of attraction on the valence shell electron will decrease. So removal of electron will be easy. So here we can say that IP is proportional to 1 by atomic size. If atomic size increases, value of IP decreases. If atomic size decreases, value of IP increases. Now let us talk about IP in a group or in a period. When we move from top to bottom in a group, what happens? Atomic size increases due to progressive addition of new energy levels. Distance between nucleus and valence shell will increase, due to which force of attraction between nucleus and valence shell electron will decrease. So removal of electron will be easy. So here we can say that when we move top to bottom in a group, value of IP decreases. Now what happens along a period? When we move from left to right in a period, atomic size decreases, because in the nucleus addition of protons takes place, and for each addition of proton, one extra electron is added to same energy level. There is an increase in number of protons in the nucleus and there is an increase in the number of electrons in the valence shell. Valence shell remains same. Force of attraction increases, atomic size decreases, and if atomic size decreases, value of IP will increase. So here we can say that when we move left to right in a period, atomic size decreases and value of IP will increase. Atoms with low value of IP can lose electron easily. And if an atom or an element can lose electron easily, it will be treated as electropositive element. All metals have low value of ionization potential due to large size. If value of IP is more, loss of electron is not easy. In that case, addition of electron is easy. Which elements can take electron? Simply electronegative elements, or we can say non-metals. So elements with high value of IP will be non-metallic or will be electronegative in nature. Now here we got N plus, we get N plus 2, we get N plus 3. In general, whenever we talk about the values of IP1, IP2 and IP3, it is found that the value of IP3 is more than the value of IP2 is more than the value of IP1. Value of IP1 is lowest here. It is general, not always. It is a general trend. Why value of IP1 is less? Reason is very simple. Because here electron is removed from electrically neutral atom. But when it is converted to M plus ion, positive charge is there. So removing electron from a positively charged species is not easy. There will be more force of attraction over the valence electron. And when it gets converted to M plus 2 ion, force of attraction will be more. So removal becomes difficult from here. So in general it is written IP3 is more than IP2 is more than IP1. Elements with the low value of IP will be metals, electropositive elements. Elements with high value of IP will be non-metallic or will be electronegative in nature. Then comes definition number second is electron gain enthalpy, which is also called electron affinity. Now, electron affinity or second one, electron gain enthalpy. Whenever term enthalpy is there, it means energy. Ionization potential, ionization energy, again it's the energy required. If energy is required, energy is absorbed for the removal of electron, then the process is called endothermic process. Energy is absorbed. Now let us talk about electron gain enthalpy or electron affinity. Affinity. How easily an electron can be added to valence shell electron? Definitely removal and addition of electron takes place from valence shell. If an electron is added to valence shell easily, then we will say that atom is having more electron affinity. And if electron cannot be added easily in the valence shell, then we will say that atom is having less value of electron affinity. Now let us convert into electron gain enthalpy. What is the definition? The energy released when an electron is added to valence shell in an isolated gaseous atom. When an electron is added to valence shell of an isolated gaseous atom, the energy released is called electron gain enthalpy. Energy released, it means process is exothermic in nature. Why energy is released? Because between the electron which is coming in the valence shell and nucleus, there is a force of attraction. Whenever opposite charges approaches each other, then energy is always released. So how we can write? We can write X in gas state, when electron is added to the valence shell, it gets converted to X minus gas with the release of energy. This energy is called electron gain enthalpy. Because the energy is released, so most of the time we use term negative electron gain enthalpy. Because energy is going out, it is decreasing. So we normally use negative electron gain enthalpy. More is the value for negative electron gain enthalpy. More negative the value is. For what? For electron gain enthalpy. More easily the electron will be added to valence shell. Less negative the value is, less easily the electron will be added to the valence shell. Now when electron is added, one electron is added, it gets converted to X minus gas with the release of energy. Now we are having X minus ion. Now if we want to add one more electron in X minus gas state, then here energy is to be supplied. Reason is very simple. When one electron is added, we got X minus. Minus is already there. It is an anion, it is a negative ion. So electron will feel force of repulsion. So if we want to diminish this force of repulsion, then we have to supply energy from outside. In this manner we can add electron. So here energy is needed. And when energy is given, it will be converted to X minus 2 gas. So first electron gain enthalpy is negative, while the other one, second, third, fourth, it becomes positive in nature. So step 1 is exothermic, while the remaining process will be endothermic in nature. While ionization potential will always be endothermic in nature. Energy will be required. About the factors, electron affinity or electron enthalpy is proportional to 1 by atomic size. Means if the atomic size increases, electron affinity decreases. We will obtain less negative value for electron enthalpy. If atomic size decreases, then we will obtain more negative value for electron gain enthalpy. Reason is very simple. If an atom is small, then its valence shell will be close to nucleus. And if the valence shell is close to nucleus, addition of electron will be easy. If addition of electron is easy, then release of energy will be more. If atomic size is more, on the other hand, then valence shell will be far away from the nucleus. The incoming electron or the electron which is coming in the valence shell will feel less force of attraction. And if there is less force of attraction, release of energy will be less. So IP proportional to 1 by atomic size and electron affinity proportional to 1 by atomic size. Let us talk about EA. in a group and a longer period. When we talk about a group, when we move from top to bottom, atomic size increases. Valence shell is going away from the nucleus. So electron affinity or electron gain enthalpy will decrease. When we move from left to right in a period, atomic size decreases. Valence shell is coming closer to the nucleus. So value of electron gain enthalpy will increase, negative value. Or in other words, we can say electron affinity will increase. Metals are not taking electrons, while non-metals are taking electrons. So non-metals have more value for electron affinity, or we can say they have more negative value for electron gain enthalpy. So these two terms are very important because metallic character or non-metallic character is directly decided by the value of IP and value of EA. Again, unit is electron volt. 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. In next lecture, we will talk about the classification of periodic table into S block, P block, D block and F block. That's all for today. Thank you and have a good day.